In this video, we'll talk about data indexing and data selection in pandas in more details. Once again, a very important concept in pandas is that we have an index object. The index object can be used to select the values in the series and in the data frame. Let's take a look at this example here. In this example, we have a series in which we constructed manually by providing the values and also providing the index. To access a certain value knowing the index, we use the square bracket operator, and this is basically the indexing and the selection operator in pandas. Now, what we do in here, we're basically asking what's the value associated with b, and the value associated with b is 0.5. Now, the series object acts very much like a dictionary. If I say a in data, it's kind of equivalent to saying a in data.index. Okay. If I want to know whether a certain value is in the series, I don't do this. I can, for instance, if I want to do 0.5 is in data, that's not going to work because 0.5 is one of the values. It's not the index. So I need to say 0.5 in data.values rather than data.index or data. Now, similarly, we can access the index object using data.index or using data.keys. And again, here I want to outline that a series is acting very similar to a dictionary in which we have a bunch of keys and a bunch of values. The function items basically give us these items as tuples of keys and values, very much like the function items in a dictionary. Now we can use indexing in both read and write mode. So I can add a new value associated with E. Right now the series itself doesn't have a value E, it has A, B, C, D, right? There's no value associated with E, but I can say, for instance, data E is equal to 1.25, and now data has another entry which is E. I can also change an existing value. So for instance, let's say I want to change the value associated with A, and I want to put it to be minus 0.25. Right now I have changed this value, the data itself, so I have minus 0.25 instead of 0.25. So far, all of these operations are selecting one value. Giving one index, give me one value back, or change a value. I can also access multiple values. I can select multiple values by using slicing. So once again, the pandas series is now acting kind of like a hybrid between a list and a dictionary. We can slice it very much like a list, but we can make the slice on an explicit index, not a number, for instance 0 to something here. So a slice from A to C will give me the values associated with A, B, and C. Now what I want you to notice in here is that when I did this slice, it gave me back all of the elements A, B, and C. And this is important to notice that whenever we provide an index to our series, this index is called the explicit index, because we explicitly provided an index to pandas, and pandas is using this index. Now, whether we provide an explicit index or we don't provide an explicit index, you need to know that pandas, in addition to the explicit index, has an implicit integer index. And that's the case for both the series and the data frame. And the implicit index is very much like the index of a list in Python. It goes from 0 to length minus 1. So if I do here data at 0, I'm going to get minus 0.25, which is the same what I get if I do data at A. This is using the explicit index, and this is using the implicit index. Now, the question is, why is it the case? Why do we have access to an explicit index and an implicit index? Once again, this has to do with the philosophy of providing different ways to do the same things. The implicit index is useful if you want to get, for instance, a bunch of observations, a bunch of values without caring about the index. Maybe I just want to get the first 5, last 5, next 5 observations in a series. The explicit index is useful if we provide the index, first of all, and second is useful because we specifically ask for values associated with known keys. So that said, we can also slice using the implicit index, very much like slicing a list. If I slice my series from 0 to 2, I get a slice from the series. Now you need to note the difference in here. When I sliced using the explicit index, the slice was inclusive in both the beginning, the start, and the end. So when I did my slice A to C, I get A, B, and C. So slicing using the explicit index is inclusive on both the start and the end. However, slicing using the implicit index is inclusive in the start and exclusive at the end, simply matching the Python nomenclature when we do slicing on a list. So far we've used two operations, indexing and slicing, and both of them use the square bracket operator. Indexing is using a square bracket operator with one value, and slicing is using the square bracket operator with a slice, and both indexing and slicing can operate on the explicit index and on the implicit index. The other very useful operation is selection based on the values, because both indexing and slicing are selecting both on the index. But let's say I want to select based on the values. Let's say I want values which are greater than a certain value, for instance. Or let's say I want to have, a certain range of values, or negative numbers or positive numbers, so to speak. Selection on the values in pandas is supported by a function called masking. So what is masking? Masking basically is an operation that creates a mask. You can think about the mask as kind of a sieve that tells you which observations you want to keep and what observations you don't want to keep. In this mask, the sieve is created as a series of Boolean values. True means I want to keep this observation, and false means I don't want to keep this observation. I'm going to recreate the series again, and I'm going to introduce masking by creating a manual mask, and then we're going to create more sophisticated masks which are more useful than manually creating the mask. Okay, that's my series, and here's what I'm going to do. I'm going to create another series called mask. And here, let's say I want to keep 0.5 and 0.75. So in my mask, I don't want 0.25, so I'm going to say false. I want to keep 0.5, so I'm going to say true. 0.75, I want to say true. 1.0 false. In my mask, as you can see here, is another series that has the same index, but instead of having values, real values, it has Boolean values, which basically telling me which one of the original values I want to keep and which one I don't want to keep. Now the second step after creating the mask is to use the mask, and we use the mask using the same bracket operator. I use the mask here, data bracket mask, and what I get a subseries, which is the result of applying this mask. Because I only want to keep B and C true, I only get 0.5 and 0.75. That's conceptually how the mask operates. We don't construct mask manually. It defeats the purpose if I want to create another series and manually put each value to be true or false. We construct mask by usually doing some Boolean operations on the series. Let's take a look here. Here I constructed my mask by conducting this Boolean operation. Data is greater than 0.3 and data is less than 0.8. What does that mean? Let's run each one of these constituents on its own. Data is greater than 0.3 is basically a Boolean operation. When we compare a series with a value, pandas is going to do this comparison across all of the values in the series. That's something we will look at in the next lecture. That's a concept called broadcasting. It basically broadcasts this operation across all of the values. So data greater than 0.3 is basically false for the first entry. True, true, true. Okay, so that's a mask. Let's call this one mask 1. Now, if I do data at mask 1, I'm going to get 0.5 and 0.75 and 1.0. Those are all of the values which are greater than 0.3. Now, in the second part here, I'm doing the comparison data is less than 0.8, which is giving me true, 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 and false because the last one is greater than 0.8. So that's another mask, and let's call it mask 2 for the sake of this example. And if I do data at mask 2, I get 0.25, 0.5, and 0.75. Okay. But ultimately, I only want B and C. So I want the data values which are in between greater than 0.3 and less than 0.8. So what the AND operation is doing is basically combining the two masks. So if I do mask 1 and mask 2, I'm going to get false, true, true, and false. So that's the AND operation here. So basically what I'm doing here, I'm doing data at mask 1 and mask 2. Actually, let's do it. Let's create another mask here. That's another mask, and I'm just doing data at mask 3, which is only keeping B and C. Now, very often we don't write all of these detailed code for creating these masks, and this cell here is doing this in one shot. It's basically creating one mask, only picking values which are greater than 0.3, another mask picking up values which are less than 0.8, and combining both of them using an AND operation, and we get the same result. Alright, so far we learned about 3 selection operations. We learned about indexing, we learned about slicing, and we learned about masking. The fourth one is called fancy indexing. And this is actually an operation we've seen in the last exercise. Fancy indexing is simply picking up multiple values of the index. And these values of the index that I'm picking on, I provide these values in a list. So for instance, in my data here, if I want to pick A, and I don't have an E here, so I'm going to get an error in this cell. I'm going to get an error because I don't have an E. Let's say I want to pick A and D. It's basically picking up values 0.25 and 1.00. The problem here is that I cannot write a slice. If those values were adjacent, I can write a slice, but those values are not adjacent. Let's say I want to pick A, D, and C in that order, right? So even if I want to pick the values in a different order, I cannot do a slice anymore, but I can do fancy indexing. What it's simply doing, it's giving me a sub-series, a slice, but not using the adjacent values of the index. It's giving me specifically what I'm providing it. I want A, D, and C in that order, so I get it. I can also repeat the same value again if I wish to. Let's say I want to have A, D, C, and again A, and I will get that. Once again, you notice that the index in pandas is not necessarily unique. So what I get here is a series that contains an index that contains a duplicate, which is fine. So that's the fourth data selection operation. So the 3 operations, indexing, slicing, and fancy indexing, operate on the index. Masking is the only operation that operates on the values. Alright, so now we are going to talk more about indexers. What we have done so far in this exercise, the pandas was operating on the explicit index of the series. But we also know that a series may contain an explicit index, but it also has an implicit index. It's possible to use both the implicit index and the explicit index. So if we don't specify what index we want to use, Pandas is going to use the explicit index if it exists. However, we can be more specific and tell Pandas that, you know, I want to use the explicit index by using an operator called loc, or if you want to use the implicit index, we can use an operator called iloc. Let's take a look at this example here. In this example, I'm creating a series that has the values ABC and the index is 1, 3, 5. Okay, so let's say I put data and I want to select the value associated with 1. Do I get A or do I get B? The answer here is A, because I provided an explicit index and hence I forgo the implicit index, which goes 0, 1, 2. This is equivalent of saying data.loc1. Loc refers to the explicit index, and data.loc1 is giving me the value associated with the index. The explicit value of the index is 1. What if I want to use the implicit index, which goes 0, 1, 2, and I want to select data at location 1, which is B in this case? If I want to use the implicit index, then instead of using loc, I'm going to use iloc for implicit index, and what I get is B because that's the value associated with 1, 0, 1, 2. Once again, if you don't provide whether you want to use explicit or implicit index, Panda is going to use a default choice. Now, I have stated before that if you don't state it, Pandas will use the explicit index. Well, that's true for simple indexing, but Pandas has many default choices that it makes under the hood, and it's important to understand these default choices. So it uses the explicit index when we index. However, if we slice, it uses the implicit index. And this is because many often when we slice with numbers, we basically want a slice using the implicit index. That's the default choice that Pandas implements. Let's take a look at data one more time. Data 1 to 3 is basically giving me a slice on the implicit index, so it's giving me the element at location 1, which is B, location 2, which is C, and because it's a slice on the implicit index, it's exclusive, so it stops at C. What if I want A and B? What if I want to use the explicit index? Well, you should know the answer by now. Instead of saying data 1 to 3 and let Pandas do the default choice, you have to be specific and you say, okay, I want to use the explicit index. And now my slice goes from 1 to 3 and it's inclusive on both ends. This one is equivalent to saying data.iloc 1 to 3. So if you're just learning this for the first time, this probably makes sense to be always specific. Just use loc and iloc. With some practice, you will come to internalize some of the default choices that Pandas does, and you'll probably appreciate that those default choices make sense most of the time. Next, let's talk about data selection in data frames. Data selection in data frames is an extension of data selection in the series. And don't forget that a data frame is a two-dimensional data structure. A series is a unidimensional data structure. A data frame is two-dimensional. It has two axes, rows and columns. It has two indices, the row index or index and the column index or columns. So when we select, we need, depending on what we want to do, we want to provide either selection criteria on one of these two axes. Say I want to select a whole column or a whole row. or selection criteria on both of them. If I want to pick specific value or a bunch of specific values, I need to provide the both selection criteria on the two axes. We have seen how to select one column from the data frame. If I do data area, I'm going to get a series, which is basically the series representing the column area in my data frame. Similarly, if I do data pop, I'm going to get another series, which is the series representing the population column in the data frame. So when I use the square bracket operator, by default, when I select one value, Pandas is going to select on the columns axis. Pandas also has a shortcut. If I want to pull a column, I can use the dot operator. The dot operator works fine as long as the name of the column doesn't create a conflict. For instance, if the name of the column has a space, obviously I cannot use the dot operator. If the name of the column is also a built-in function, such as a function called pop, this doesn't give me the column itself, it gives me the function. And thus, many often I use the bracket operator to pull a column rather than the dot operator. Next, what I'm doing here, basically, I'm pulling two series, data population and data area, and then I'm dividing population over area. That basically gives me a new series. Now, this new series, as you can see here, has the same index because it's built by dividing the values of population over the values of area. What I can do in using this series, I can put it back into my data frame if I wish to do so, effectively creating a third column of my data frame. That's basically to show that this selection operator can also be used in read and write mode. I can access one series, but I can also put a series, which is the result of the division operator, back to my data frame. So if I do this, now my data frame has three columns: area, population, and density. The T operator basically creates the transpose of the data frame. It basically swaps the two axes, the columns become a row and the rows become a column. This is a very useful operation. Many often we'll come to know how to select on the rows or the columns more easily. So if you want to do the same operation on the other axis, we can do the transpose and do the selection. However, with more practice, you'll get to know how to index and select in both axes. So probably you will not need the transpose operations unless if you specifically need to transpose your data frame. Let's talk in more details about selection on Pandas data frame. So starting from this basic operation, I'm basically selecting on the columns axis. I'm selecting one value on the column axis. Select a value on the columns. What if, for instance, I want to select one row in my data frame? Let's say I want to select the row associated with Texas in this case. Can I do something like this? This doesn't work because Texas is not a key on the columns axis. Once again, Pandas is making some default choices here. And there are now two default choices that are decided under the hood: whether to use the implicit or the explicit index, and whether to use or to select on the columns or the row axis. Right? There are two default decisions are being made in here. By default, it's using the explicit index when you select one value, and by default, when you select one value, it's accessing the columns axis. If you want to select based on the row axis, then you need to specify the indexer that you want to use, which is loc in this case, because Texas is on the explicit index. And when you do loc, you're basically selecting on the row axis. And if you do data.loc Texas, that basically gives you a series. If you take a look at this series, the index is basically the columns and the values are the values here, right? So it's created a series in which the index is the columns and the values are obviously these values here. Similarly, if you select one column like area, it's basically giving you a series in which the index is the row index. So you can think about those two operations are very similar. If you select a column, you get a series that has the row index. If you select a row, you get a series that has the column index. Now this operation is equivalent of saying data loc area. However, you want to select the rows here. If you want to select all of the rows, you do just the colon here operator, and basically you get all of the rows. Similarly, this one is equivalent of saying, well, why don't you give me Texas and all the columns here, and that will give you Texas in all the columns. So then what I want you to understand in here is that the loc operator here has two entries, what you want to select on the row axis and what you want to select on the column axis. Once again, this is because the data frame is a two-dimensional data structure, so you need to provide two coordinates. If you don't provide the two coordinates, by default, Pandas is going to assume that the first coordinate is the row axis. So if you want to select on rows, that's fine, no issues. But if you want to select on columns, you have to use the colon operator. Once again, that's using the explicit index. What if you want to use the implicit index? You can do that. Let's take a look at the data frame again. And now if we take a look at this data frame, if you do iloc, and that's a slice from the beginning from 0 to 3, that's going to give you the first 3 rows, California, Texas, and, well, let's do it again. That's an old data, California, Texas, and New York. And column 2, which is equivalent to 0 to 2, is going to give you the first 2 columns, area and population. So this selection operation sliced on both the row axis and the column axis and gave you back a data frame. It's a subset. It's a sub data frame from the original data frame here. Similarly, we can use, if I want to get California to New York, I can use the explicit index. So I want to go from the beginning, which is California, to New York. So I'm going to type in here New York. And I want to go from the beginning to population. Notice that the slice operator here is inclusive on both ends, the start and the end. This one is exclusive because it's using the implicit index, and we basically get the same slice. All right, so I know by now you're probably a bit confused, and the source of confusion is that there are so many things going on right now when we have a data frame. So let me break these things to you. When we have a data frame such as data, this bracket operators mean many things. It's basically selecting. But it's basically selecting on what you put into it. If you put one value, it's going to select a column. If you put 2 values, it's going to select a row, because usually slicing is done on the rows. So if you do in the beginning to New York, it's going to give you in the beginning to New York. So if you don't want to live in confusion, if you don't want to live by the default choices that Pandas is doing, then don't use this bracket operator and use instead either loc or iloc. So data.loc or data.iloc takes 2 coordinates because it's a data frame. The row, what you want to select on your rows, and what you want to select on your columns. Okay. So for instance, let's say you want to select, let's take a look at data again. Let's say you want to select the population of New York. Then on your row column, you put New York. And on your columns axis, you put POP for population, and you get exactly that value. You're basically selecting by providing the two coordinates on the row axis on the column axis. Now, if you want to select all values associated with New York, meaning area, population, and density, then what you can do, you can put a column here, and that will give you a series of these values now. Similarly, if you want to select all of the states, the population of all of the states, you can put here a column instead of the state name, and you basically get all of these states. You also need to understand that in both of these two coordinates, you have access to single value indexing, slicing, fancy indexing, and masking. I know this is getting a bit dense, but bear with me for a minute. Let's take a look at data one more time. Let's say I want to select these states that have a density more than 100, but I want also only to pull population and density. So that's a masking operation, and that's fancy indexing. And I can do both of them using the loc operator. Let's break this kind of dense operation to steps. If I do data.loc, I basically want to select on two axes. What do I want to select here? This one is easy. I'm selecting two columns, so I can use fancy indexing. If I put column here, I'm basically selecting all rows and only these two columns. But I don't want to select all rows. I only want to select states that have a certain density, more than 100, for the sake of this example here. So what do I do then? Then I can use masking, right? Don't forget that data.density is giving you back a series. And if you compare it to a number, you get a mask. And then you can use this mask to select. And we've used masking to select on a series. You can use a mask to select on a data frame. You select the rows on the data frame. And hence, we are looking here for a subset of the data frame that have density more than 100. But we only want the two columns, population and density. So the loc operator and also the iloc operator takes two coordinates on the two axes. And each one of these two coordinates can be one of the selection operations we looked at. Indexing, single value indexing, slicing, fancy indexing, and also masking. Finally, you can change as well if you want to change the value in write mode. We seldom do that because many often we read the data and process it. But if we wish to select and override a certain value, we can use either iloc or loc depending on the operation. I'm going to go quickly over some of the indexing conventions. We've probably covered many of them. Those are basically the default choices that Pandas does. So if we slice, and again, when we don't provide .loc or .iloc, we're basically letting Pandas make these default choices. So when we slice, by default, it slices on the row axis. When we slice by numbers, it's going to refer to rows and is going to use the implicit index. When we do masking, by default, it also interprets this as masking on the row axis. So those are some of the default choices that Pandas made. Once again, you can completely determine what you want to do by using either loc or iloc. The moment you use loc or iloc, don't forget you need to provide the two coordinates, the row axis and the column axis. And those two coordinates can be either single values indexing, slices, bunch of values, fancy indexing, or masking, or any combination of these operations on the two axes. And that basically gives you a wide range of very powerful data selection operation. And the only way to get and master these operations is to practice them. We will do that in the next exercise.